Okay, so for our hypothesis testing, we are either going to use, so we're going to be either testing a mean, population mean, we'll be testing, or a population proportion, right? So recall that X bar is approximately normally distributed with mu of the population and then standard deviation sigma s over square root of n, right, where n is yeah, the sample size, right? Or we use a t distribution with certain degrees of freedom. Now, if we use the t distribution, right, that's what we're going to call the t-test. And in that case, we'll use the student t distribution. Right? And again, a couple conditions need to be met, right? Those conditions being that we have a simple random sample. The population is approximately normally distribution. Excuse me. The population is approximately normally distributed. Right, and we use the sample standard deviation. Okay, now as always, if n is sufficiently large, then the population does not need to be normally distributed. And population does not need to be normally distributed. Okay, all right. Now, the other type of test when dealing with population means, now again, population mean is random variables that are that can be measured, right? Like let's say height, right, or time it takes to do a certain thing, etc. Right? Now we do the t-test. The other alternative is that we do the z-test, where our distribution that we will be using for our z-test is the normal distribution. Right now, here, so in this case, we use the normal distribution. But in this case, a couple of parameters need to be met, right? The one is that the population is normal, or n is sufficiently large. All right. Now, another thing that must be satisfied in order to use the z-test is that we know the population standard deviation. Now, this is in most applicable cases, this probably won't be information available to us, but let's say if we did happen to know it, then we would use a z-test. All right, so if those conditions are satisfied, we use a z-test where we use the normal distribution. If not, right, we default to the t-test where we use the student t distribution. Okay. All right. Now, the other type of hypothesis testing, or the other type of data that we'll be testing, that we'll be using a hypothesis test for, is for the population proportion. Okay. Okay. So for the population proportion, right? So again, this is when questions not necessarily not something that is measured, but more if we ask a question that has two results, right? Maybe like a yes or no, or some condition is satisfied, right? Where there are just really two binary. It's a binary decision, right? Like percentage. Like if you ask someone, you know, we want to determine the percentage of people that smoke, right? So the question would be, do you smoke cigarettes? Yes or no, etc. All right. So in this case, our sample, which we'll call P prime, right, where it will be normally distributed with mean of whatever the population proportion is, and standard deviation P times Q over N. All right. We call P, right, the probability of a success, right? So if we know that uh, the population, let's say 30% are smoke cigarettes, all right, then that would be our P, right? That would be our previous value, and the one that we are going to test whether it is not true. Okay, now our P prime, our sample population proportion is X over N, where again X is the number of successes from our population, right? And again, N is, as always, the sample size. Okay, and then also recall here that if P is the probability of a success, Q is the probability of not a success, right? And since both of those add up to 1, Q is always 1 minus P. Okay, now in this case, we'll always use a normal distribution for our hypothesis testing, as long as two conditions are met. That being that N times P is greater than 5 and N times Q is greater than 5. Okay, so as long as both of these conditions are met, right, then we are going to move forward and use the normal distribution. Okay, so these are the conditions for the distributions to use for our hypothesis testing.